Have you ever wondered what it might be like to do voice blending? There's plenty of voice cloning tools out there, but voice blending? Not so much. Picture taking two different existing voices and then blending them into one. Like if you took Alfred and Batman. Alfred's got a voice like this, in a Cockney accent.
Batman's got a deeper thing like this.
And if you were to mix them together, you might end up with a grovelly, deep voice of Batman, but also with a Cockney accent. Now, there aren't really a lot of tools out there that are going to allow you to do this. There are a few that I found, but those are primarily designed for singers. And there's not really that many that have API endpoints. So developers are kind of left in the dark when they're trying to build their own tools. Now, when we think about voice cloning and mixing, we might think of a company like ElevenLabs. They're the go-to industry standard for all things voice AI. But they don't explicitly have a voice blending API endpoint. I wanted to figure out if I could make ElevenLabs do voice blending, even though it really isn't supposed to do that, and then compare it to an API endpoint like Cartesia that does have that. Now, before we actually get into blending, we actually have to think about what is a voice, and therefore, how do we blend that? For a lot of companies like ElevenLabs or Cartesia, they have what's called an internal embedding of a voice. For Cartesia, their embedding is a 192 length vector, and each one of the values in that vector contributes to the style of a voice. For ElevenLabs, we don't know. They keep their embedding proprietary. But within this embedding, it's describing all of the characteristics that define that voice. Slightly different than an actual audio file or a waveform which you or I might hear. A voice might be able to produce multiple different waveforms. So blending waveforms isn't exactly the same thing as blending a voice. Using this knowledge of the existing ElevenLabs API and Cartesia's API, I wanted to compare them. Could I get ElevenLabs to voice blend in the way that Cartesia does? Let's get into it. If you download the repo here at the Voice Blender link in this description, you'll be able to see both a React front end and a Python backend. And when you npm run dev, go to localhost 5173, you'll see something like this. This is just a very basic React front end that I built, pretty standard TypeScript components. You'll also have to use the Python backend by running this uvcorn command. Once you do that, your Python backend is going to be working. Heading back over to the browser, you're going to end up seeing something like this. Now, this experiment is primarily for ElevenLabs. So the first thing that we do is we get all the voices available to our ElevenLabs account, and we're going to be able to have them in a dropdown. So here I have all of these different ElevenLabs voices. I can choose two different ones of them. Now, then I can put in the text with whatever I want those voices to say. Now here in blend method, I have 4 different settings. 3 of them are for ElevenLabs and 1 is for Cartesia. So ElevenLabs already has 3 different endpoints that I thought might be able to help us in this adventure. The first is the speech-to-speech endpoint. Now, when we think about what that is supposed to do, it's taking one voice in the ElevenLabs platform, uploading another audio file, and transforming that original voice into the style of that audio file. Now, that really isn't the type of voice blending that I'm going for in this experiment, and here's why. When you think of a voice, it actually has 3 different components: the identity, the expression, and then the content. The identity of a voice is the deep qualities of a voice that make that voice that voice. These are things like the timbre or the formant structure. The things that make your voice and my voice my voice. The expression of a voice are the things that we can change. Things like the pitch or the speed in which we talk or the intonation, the emotion of our talks. So if I'm talking a little bit faster and I enunciate upwards of my voice as opposed to bringing them down, these are things that we can change. That's called the expression. The content is the words and the phonemes of the actual sounds that we're saying. So what this speech-to-speech endpoint is supposed to do is take the identity from one voice and the expression and the content from another audio sample and mixing them together. So it's not exactly the voice blending that I'm going for because I want to be able to mix the identity of voices, but I think it's a really good baseline, and ElevenLabs already provides that endpoint. So let's see what happens when we select two voices, Roger and Callum, put in some text to speak, select our blend method. For right now, we'll just do 50% to make it even, and click blend voices. And what we get out, we can see we have a primary voice audio player, secondary voice audio player, and then the blended result. So let's see how it sounds.
Hello, this is a blended voice demonstration. I want to show you that I can talk in long-winded sentences that go on and on and on, but I can also articulate in short bursts.
Okay. Very clear, well-defined American voice. Very strong.
Hello, this is a blended voice demonstration. I want to show you that I can talk in long-winded sentences that go on and on and on, but I can also articulate in short bursts.
Okay. A little bit more grovelly, deeper. Let's see what the blended voice result is.
Hello, this is a blended voice demonstration. I want to show you that I can talk in long-winded sentences that go on and on and on, but I can also articulate in short bursts.
Okay, I definitely hear a bit of both there. It's a little bit more grovelly than the first, but I can definitely sense the identity of the first voice. Now, one way to compare this blended result is just listening to it, but I also included something here called a spectrogram. A spectrogram is a visual representation of the frequencies of an audio sample. So here, if we zoom in to just the beginning part of the first voice, the beginning part of the second voice, and the beginning part of the third voice, visually, we might be able to see some sort of in-between between the first and second voice in the blended result. So here in the primary voice, that was a very clear voice. So it's not surprising that we see these very clear bands of audio. That second voice was a little bit more grovelly, so perhaps that's why we see a little less clear defined bands. And that third voice, maybe that's somewhere in between. A little hard to tell. It's not perfect, but it is a good way to check, like, is this result somewhere in the between of our first and second voice? All right, now let's go on to the next endpoint from ElevenLabs. This is the text to voice endpoint. And what it's supposed to do is you're able to create a voice or a voice embedding from a text description. For example, you might be able to say something like, create a raspy male Boston accent voice, and then it would create the embedding for that. Now, I wanted to know, could you put the voice IDs of other voices already in the ElevenLabs platform into that description? Nowhere in the ElevenLabs documentation it says you can't, so I figured I'd try. All right, so let's try. So again, we have that same selection of voices. We click blend voices. It will take a moment to blend them. And here we are. So let's see. So the primary voices and the secondary voice are going to be pretty much the same as before.
Hello, this is a blended voice demonstration.
Clear, strong American accent.
Hello, this is a blended voice demonstration. I want to show...
A little bit more grovelly. Let's see what the result is.
Hello, this is a blended voice demonstration. I want to show you that
No. Okay, so that did not work at all. Worth a shot, but that definitely did not work. So that's confirmation that in the the text to voice endpoint, that it cannot recognize voice IDs. Okay, on to the next one. All right, for this one, this is the ElevenLabs instant voice cloning. Now, this endpoint takes in one or more audio files from a voice that you want to clone. Now, I thought, well, what if we take the audio files from multiple different voices? Would it be able to blend those voices as it creates this new embedding? Worth a shot. Now, it's important to remember that with this endpoint, the more audio that you give it, the more accurate it might be. So I'm going to put in a slightly longer prompt, because what I'm doing under the hood here is taking this prompt, creating audio files from these two voices, and then inputting them into this IVC endpoint. So I'm going to take a ChatGPT slightly longer script that I said is about a minute, and we're going to click blend. You'll notice here that the blend control is locked at 50%. That's because I'm guaranteeing that there's going to be 50% of the input audio from the voice 1 and 50% from voice 2. So let's see what happens when we blend these voices. Okay, so playing this first voice.
Hello there. Thanks for tuning in. This is a test script designed to capture the full range of a human voice, bright and cheerful, calm and curious.
Okay. Second voice, same
Hello
one.
there. Thanks for tuning in. This is a test script designed to capture the full range of a human voice.
Okay, let's see what happens to the blended result.
Hello there. Thanks for tuning in. This is a test script designed to capture the full range of a human voice. Bright and cheerful, calm and curious. We'll try a little bit of everything.
I would say that's pretty good. You can kind of hear that forward confidentness of that first voice, but there's definitely some groveliness of that second voice. Probably not perfect, but definitely approximate. From the tests that I've done with this one, it's sometimes a hit or a miss. This one worked okay, but for some of them, it's been way off. So it's not really consistent, and I think it depends on the two input voices that you put in. Okay, so as a review of the ElevenLabs, speech-to-speech endpoint worked as expected. It transfers the expression and the content of one audio file to the voice of another. The text method, where we input the voice IDs into a description, completely did not work. And this instant voice control kind of worked, and I would say it works inconsistently. All right, now let's try Cartesia. Cartesia is a company like ElevenLabs, and they do have an API. It's much less extensive than ElevenLabs, so I typically still lean ElevenLabs when I'm doing my work, but they do have an endpoint called Mix, which allows you to mix different embeddings. What I'm doing for this method is I'm still taking the ElevenLabs voice, cloning it into Cartesia, and then mixing it using Cartesia's mixing endpoint. So let's see how this works. So again, that primary voice,
Hello there. Thanks for tuning in.
strong, American sounding male voice,
Hello there. Thanks for tuning in.
bit slower, grovelly, blended result.
Hello there. Thanks for tuning in. This is a test script designed to capture the full range of a human voice. Bright and cheerful, calm and curious. We'll try a little bit of everything. Let's warm up with the story. Once upon a time, there was a young explorer who...
Okay, I would say that's kind of in between. What's interesting is that it actually is a bit quicker, as you'll see, than the two inputs. From the tests that I have done, this does tend to work quite well. Let's try another input. All right, this first voice again.
Hello, this is a blended voice demonstration.
This is a blended voice demonstration.
Hello, this is a blended voice demonstration.
Hello, this is a blended voice demonstration.
And the result.
Hello, this is a blended voice demonstration. I want to show you that I can talk in long-winded sentences that go on and on and on, but I can also articulate...
Kind of the same thing. It does kind of hit in the middle there. It's not perfect. I can hear aspects of both, but in this experiment, it's probably the same as the IVC when the IVC has a long input. And let's just check the spectrogram. Very clear bands from that first voice. A bit more grovelly blended bands from that second voice. And let's see where we end up on this third voice. Maybe somewhere kind of in the middle, so maybe that's an approximate. In addition to this spectral analysis, I also have these what's called MCD, mel-cepstral distortion, which is basically a way of comparing two audio samples and how similar they are. Here I compare the primary with the blended and then the secondary with the blended, and it produces a score. You don't have to know how it's calculated, but basically the closer these two are, that would be more of a 50% blend. Now, if I were to blend down here with a 98 and 2, and I blend those voices, let's see what this, theoretically, this should go up. And indeed it did. So This means that the blended got closer to the primary, the blended got farther away from the secondary, so the difference between them expanded. So while that's a really coarse measurement, it's kind of a way to measure, all right, how similar are these audio samples? All right, that's a wrap for voice blending with ElevenLabs and Cartesia. What we discovered is that you can sort of do voice blending with ElevenLabs. 3 different ways are going to get you 3 very different results. Text to voice did not really work at all. The speech to speech is a form of voice blending, and the IVC is going to be the closest you can get with ElevenLabs if you provided enough audio. By contrast, you can do it naturally in Cartesia. So as we look forward to voice blending, a couple of wants and wishes. One is that I actually want an endpoint with ElevenLabs like Cartesia's endpoint. 2, and I think perhaps more importantly, is I want to be able to access voice IDs in text descriptions. Not necessarily for voice blending, but just in general. Let's say I wanted to create a voice, create a raspy Boston accent voice with the soft tones of voice ID XYZ. I want to be able to specify that voice ID right in the text description. And 3, I tried to approximate it here with the spectral analysis and the MCD calculation, but I wanted to be able to know and analyze my voices when I blend them. Now, ElevenLabs is probably not going to expose its embedding. That's okay. But I think there's still the opportunity to have tools that they give that will be able to let us know whether or not voices are actually blended. All right, thanks for watching. Look forward to hearing your thoughts and seeing what you build.